Hello, and welcome to our lesson on estimating the values of powers and roots of positive numbers. In this lesson, our primary focus will be on learning how to estimate the value of a power of a given positive number and the value of the root of any given positive number. After covering these core concepts, we will practice applying this knowledge to a variety of cases to solidify your understanding. So far, you have become familiar with the basic concepts of powers and roots. Specifically, powers, understanding how multiplying a number by itself multiple times results in a power, such as 2 cubed equals 8. And also, roots, recognizing that a root, such as a square root, determines what number, when multiplied by itself, gives the original number, for example, the square root of 9 equals 3. Building on this foundation, we will now introduce techniques for estimating the values of powers and roots. This is a powerful skill that allows us to quickly approximate values without tedious calculations. For instance, if you need to estimate the value of 4.4 circumflex 2, knowing how to reasonably approximate powers can save you significant time. Let's get started. Before we dive into new techniques, let's briefly recap two fundamental concepts. An exponent is the number that indicates how many times the base is multiplied by itself. For example, in 3 cubed equals 3 times 3 times 3, which equals 27, so 3 is the exponent. A square root is the number which, when multiplied by itself, gives the original number. For example, the square root of 25 equals 5 because 5 times 5 is 25. Finally, a cube root is the number which, when multiplied by itself 3 times, gives the original number. For example, the cubed root of 27 is 3 because 3 times 3 times 3 is 27. Great. Now let's move on to estimating powers and roots. Let's start with how we go about estimating the value of the power of a given number. Simplifying the base number, if possible, can make calculations easier. For example, suppose you want to estimate 5.4 circumflex 2. Since 5.4 is between 5 and 6, 5.4 circumflex 2 must be between 5 squared, which is 25, and 6 squared, which is 36. Since 5.4 is closer to 5 than it is to 6, a reasonable estimate might be 30. The actual value of 5.4 circumflex 2 is 29.16, which is not far off from our estimate. Using known powers like 16 and 25 in our example makes the process much easier. Now let's try estimating the value of a root using perfect squares and cubes. Firstly, identify the closest perfect squares or cubes to estimate the root. For example, suppose we want to estimate the square root of 50. Note that 49 equals 7 squared and 64 equals 8 squared. Therefore, the square root of 50 is slightly more than 7, so an estimate of approximately 7.1 makes sense. We find that the actual value is approximately 7.07 to 2 decimal places, which again is very close to our estimate. By familiarizing yourself with these basic techniques, you can quickly estimate the values of powers and roots of any positive number. This will be immensely helpful when you need to approximate without a calculator. Let's dive into some practice questions to understand how to estimate the value of powers and roots of positive numbers. Example 1. Estimating a power. Let's try and estimate the value of 3.7 circumflex 3. Here's our approach. Firstly, identify the nearest whole numbers for the power. We know that 3.7 is between 3 and 4. Then calculate the known powers. 3 cubed equals 27, and 4 cubed is equal to 64. Finally, estimate between these values. Since 3.7 is closer to 4 than 3, we know 3.7 circumflex 3 will be closer to 64 than 27. A reasonable estimate could be somewhere around 50, or within that sort of range. The actual value of 3.7 circumflex 3 is 50.653, which is very close to our estimate. Now let's try a final example. Estimate the value of the cube root of 20. First, let's identify the nearest cube roots. We know that 20 is between 8 and 27, since 2 cubed equals 8 and 3 cubed equals 27. Then let's estimate between these values. Since 20 is closer to 27, the cube root of 20 will be closer to 3 than 2. A reasonable estimate might be around 2.7. The actual value is approximately 2.714 to 3 decimal places, to which our estimate is quite close. These examples demonstrate how you can estimate powers and roots by identifying nearby known values and interpolating between them. This skill is particularly useful for quickly approximating values without needing exact calculations. In today's lesson, we began by revisiting the definitions of exponents, powers, and roots to ensure clarity. Specifically, we recalled that powers are the result of multiplying a base number by itself multiple times, and roots are the inverse operation, identifying which number, when multiplied by itself, yields the original number. We learnt how to estimate powers by using known powers and roots. We utilized the proximity of perfect squares and cubes to the given number and interpolation techniques. This allowed us to square roots and cube roots, as well as squares and cubes of numbers with a decimal part. Through practice problems, we solidified our understanding of these estimation techniques, emphasizing their utility in making quick, reasonable approximations without exact calculations. Watch the rest of the GCSE Maths course at Sophos Education.